All right, well, good morning, everyone. Welcome back to another exciting day in mathematics. Whoop, whoop. Warm-up 44 is on the screen, very similar to the ones we've done so far this week. Number 1, complete the square and factor. We have x squared plus 14x. Number 2, simplify. Part A is square root of -9. Part B is 5 over square root of 7. And C is square root of 70. Number 3, factor by grouping, x squared plus 9x plus 18. And number 4, find the inverse function, f inverse of x, for the given function f of x. And the given function is f of x equals -3x plus 6. Alright, since today's the minimum day, make sure you stay focused, and hopefully we'll get through this as expeditiously as possible. How about that word, expeditiously? That was pretty good, right? Alright, copy and go. Alright, let's see, number 1. What'd you get for number 1? Carlos, what'd you get? X plus 7 squared. Hands, if you got that? That is correct. How do we get there? Well, we need to complete this square. We take the coefficient of x, divided by 2, and we square it. So that becomes x squared plus 14x plus 49, because 14 divided by 2 is 7. 7 squared is 49. From there, 7 times 7, 7 plus 7, and that's how we write that. Okay? 2a. What'd you get for 2a? Noor? 3i. Hands if you got that. That is correct. How about 2b? Audrina? 5 square root 7 over 7, that is correct. And once again, for those of you that are a little bit lost, you need to multiply top and bottom times the denominator. That gives you 5 square root of 7. 7 times 7 is 49. Square root of 49 is 7, and that's how we end up with that. C. Let's see what your neighbor got. Turn to your neighbor, see what they got for that one. Alright, so this is approximately between 64 and 81, is that correct? Yeah. So that means this is 8 point something, is that correct? Yes? So you subtract, divide, that should give you 8.3 something. Hands if you got that. Yeah, okay. Number 3, what'd you get for number 3? Factors. Juliana. What? Help her out, Miguel. Oh my goodness. 6 times 3 is 18, 6 plus 3 is 9, so this 9 becomes 6x plus 3x, and I bring down the x squared and the plus 18, group, GCF here is x, we're left with x plus 6, well, that looks like a 6, no? We're left with x plus 6, GCF here is 3, we're left with x plus 6. So my factors are x plus 6, x plus 3. And last but not least, number 4. What'd you get for the inverse on this one? Adrina, pick someone. Raymond, what'd you get for number 4? What is it? F inverse of x. x over minus 6 over negative 3. Technically yes, but we're going to try not to have a negative in the denominator, so if we divide that to the numerator, we end up with f inverse of x equals negative x plus 6 over 3. But yes, that is correct. Alright, so copy the agenda for today. Warm-up number 44, transformation of functions. Home play is only 5 itty-bitty transformations only. It's going super fast. What's going on? Oh, minimum day. Let's go. All right, your Nearpod code, here we go. NER for I, NER for I. And your home plate from last night, go ahead and go to canvas, turn that in, please. Take a picture, turn it in. I'll give you time for that right now. And as you're turning that in, tonight's home play is on the screen. It's only 5 itty-bitty transformations. All right. And for those of you watching online, you're going to need a graph paper. Today's going to be a day of practice. So we're going to go straight to the practice portion of the session. But we'll wait for the rest to turn in their home plate. All right, so we're still in the same objective. I can transform functions using different parameters. But like I said, we're going to go straight to the practice. So example mega Q's on the screen. And it reads graph f of x equals x squared, and then you're going to leave a space, and then you're going to write then graph g of x equals f of x minus 2 plus 3 over 2. I'll have you copy that first, and then we'll get started right away. Copy that and go. Execute. So one of the things that I've been saying from the time that we've been doing transformations is that we're going to be working straight up with 3 functions. What are the 3 functions? The linear function, quadratic, and cubic. The parent function is the one we need to get used to graphing and writing a table for, which is this one. This is a quadratic. It's the parent function. So the very first thing when they ask you to graph these, you should start a table right away. So let's do that. And as you start it, you should be able to fill it in as you go get your table going. So for example, x, f of x. So here we go. This function says to square the x, yes? So if I substitute here negative 2, what is negative 2 times negative 2? 4. Negative 1 times negative 1, 1, 0, 0. And since it's a parabola, the values repeat now. 1, 1, 2, 4. Let's graph that. Negative 2, 4, negative 1, 1, 0, 0, 1, 1, 2, 4. This should be automatic, guys. This is the very first thing you should do every time that you get started with transformations. Graph the parent function and label it f of x. This is going to be our bread and butter the entire year. I'm going to show you something in regards to a transformation using the parent function, and from there we go and apply 2 other functions. Pretty much that's how it's going to go. So like that, every day when you wake up, you're going to be like, oh, negative 2, 4, right? It's going to be so automatic that you already got it, yes? All right. So as you're finishing that up, and before I continue, quick review. This is 6th and 7th grade. In 6th and 7th grade, your teacher introduced you to parabolas, I believe. hopefully. And they said, okay, a parabola is a happy face because it's a positive coefficient. So if you look at here, what is the invisible coefficient here of x squared? It's a 1, and it's a positive 1. That's why we get this parabola. However, if I had a negative value here, this would be a what? A sad face. That's why it's a negative. The other thing that they should have covered, or they should have mentioned, which I mentioned last week, is these points right here. This one is the minimum, and this one is the maximum. However, those two have a specific name. These are known as the vertex. They're known as the vertex. So those of you that remember Algebra 1, remember, you loved Algebra 1, and you should have covered the vertex. Okay? So, by looking at this one, what is my vertex? My vertex is right there, Mr. Q. 0, 0. Do you guys see it? Okay. We good? All right, let's move on. Let's graph the transformation. You're like, oh, snap, Mr. Q. This doesn't look anything like we've covered. Okay, well, let's start transforming. The first thing that we need to add here, since this is the quadratic, what do I need here? A squared. Okay, so there it is. Okay. Next, look what I'm going to do. There's an invisible coefficient here, which is 1 over. So if I write that like that, I brought the 2 over together with the 1. What's left? X minus 2 squared plus 3, and all that equals to g of x. Some of you are like, Mr. Q, how is that possible? You're like David Blaine and Chris Angel or something. Well, let me show you. Question. 2/3 times 5. Isn't that the same as 2 times 5 over 3? Yes, right? You're saying, I don't see it, Mr. Well, an invisible 1, so that is 2 times 5, 3 times 1 is 3. Okay, there it is. And if this is simplified, then this is 10 over 3. So if I go backwards and I said, I want you to get rid of this 3 from the denominator, go this way, and we extract the 2 over 3 as a fraction by itself, and that leaves us with 2 over 3 times 5. Same idea right here. Okay? So, before we move on to the graphing, tell your neighbor where we're going to move this to. Is it going left or right, up or down? Talk it over with your neighbor. Where is it going? Alright. Good conversation between Alexa and Brisa over there. Good. So where's it going, Alexa? To the right and up. Yes. So our final transformation we're going to do in red. And it says here that we're going to go 2 to the right and 3 up. But before that, look at this one. What is this parameter? Parameter A. What is that going to do to the original one? Tell your neighbor, what is that going to do to the original one? All right. I heard and I saw some people go like, yeah, so it's going to compress, which means it's going to open up a little bit, but it's going to compress down a little bit. So before we move it, let's do another table right here, x, and now with our parameter 1/2 times f of x. And probably some of you are saying, Mr. Q, how come you don't include the x and the h, the h and the k, because we already know where we're going to move it to. We just need to figure out the compression or the stretch. So let's see. -2 of x. What is f of x there? 4. And what is half of 4? 2, yeah. Next one, negative 1. What is f of x at negative 1? 1. What is half of 1? 1/2. And the rest is 0, 0, and then it repeats. 1, 1/2, and 2, 2. All right, let's graph that in blue. Negative 2, 2. Negative 1.5. 0, 0. 1.5. And 2, 2. Graph your parabola. Now, we're not going to label this one g of x because that's not our final transformation. That's just to show us to see if we predicted, did it compress? Yes, it did. There it is. It shrunk. Or, like some of you said, it shrunk. Okay. So now, all we have to do is take these 5 points and move them according to this. But let me show you a faster way of doing that. Writing utensils down, look up to the screen. Here it goes. Ready? Here it goes. A faster way of graphing the transformation. You start with the vertex. What is the vertex for the original one, for the blue one? 0, 0. And we're going to move it what? 2 to the right, 3 up. 2 to the right, 1, 2, 3. There it is. Now check this out. This should be this one, yes? What's on both sides of this vertex? There's 2 points. 1 step away for each side, but a half step up. So I go 1 step on each side, half step up, and I have 2 points right there. You guys see it? And then we have this one and this one. How far is that from the vertex? 2 steps to the left, 2 up. 2 steps to the right, 2 up. 2 steps to the left, 2 up. 2 steps to the right, 2 up. And that's how you graph your final transformation. Copy that, please. G of x. Some are like, nah, I like doing each point at a time, Mr. Q. All right. Well, whatever. All right, and this was pretty much last night's home plate. The only thing that changed today is I included this one that looked a little bit weird with the denominator, but we just need to know how to rewrite it. Okay. So for the sake of practice, look what I'm going to do. I'm going to create another one. I'm just going to make it up. But instead of g of x, since we're using the same graph in green, I'm going to label this one h of x. H of x, same 1/2. Then I'm going to have x plus 7 squared minus 2. Now notice that the a is still the half, so we don't have to do all this work. We already have the parent function f of x. There it is. So basically we're just going to move the blue one, because I want us to practice the translation. So tell me where it's going to move to. Where will you move the blue one to now? Alright. So where are we moving to the blue one, Lexi? 7 left. So draw your arrow to the left and 2 down. That is correct. So let's move these 5 points, but I said to start with what? The vertex. So this one. So we start 7 left, 2 down. There it is. We have 2 points, 1 on each side, 1 step away, and then 1 half step up. So half step up, half step up. And then the other 2 are 2 steps away, and then 2 steps up, 2 steps away, 2 steps up, 2 steps away, 2 steps up. And we label this h of x. Not bad, yes? Okay, let's do another one. So that was our green one, yes. Let's do, let's see. Let's do j of x. J of x equals 1/2 f x minus 6 squared minus 7. All right, before you do the whole thing, tell your neighbor where it's going, please. The blue one, where are we moving the blue one now? All right. So where are we moving? 3, 6 to the right, and 7 down. That is correct. So that means I'm going to take this vertex, the blue one, 6 to the right, 7 down. And then we have the points half a point up, but 1 step away, and then two steps to the left, 2 up, 2 steps to the right, 2 up, and there's my function, and this is our j of x. Okay? Is that plenty of practice? That help a little bit more? Yes? Okay? So what is the process? We start with the parent function. We have to have a table. You graph it. From there, you find out if it's moving, where it's moving to, and then if it has an A, you have to do a table for the A portion, so like that you can see that first. Okay, now check this out. I want to show you something. Hopefully, we can close this portion up before we move on tomorrow to the next parameter. Look up to the screen, please. So watch. My original vertex was 0, 0. Do you agree? Yes? Yeah, we started there. Okay. All right. So watch. What is the vertex of the red one? The red one is 2, 3. What is the vertex of the green one? -7, -2. Oh yes. Oh yes. What is the vertex of this last one? 6, -7. All right, talk it over your neighbor, see what we just found out right now with what I'm going over. I started with the original vertex, then I gave you these vertex according to these. Talk it over your neighbor, see what we found out. Wow, be nice. Adrena, man. Man, imagine if I was a friend like, Adrena, can I study with... Just study! Oh my goodness. Alright, let's see, what did we find out? Bree, pick someone. What did we find out, Philip? The vertices are different. Oh yes, most definitely. Okay. But we said we started with 0, 0. And this one was 2, 3. The vertex represents the parameters. Wow, that's perfectly put. Let's see. The parameter here was 2 to the right. That means a +2. And +3. There it is. Look at the green one. If we're going to the left, it's a what? -7. Is that correct? And then 2 down, which is a negative, that's where we get -7, -2. Look at this last one. 6 steps to the right, that means it's a +6. And 7 steps down, that means that's -7. That is correct. So let's close this idea right now. Let's do conclusion. Write down at the bottom if you have space, conclusion. If given g of x equals f of x minus h plus k. Now notice this is the general form and it doesn't have an exponent here, notice, because it could be applied to any function. If it's to the first exponent, second, or third. Comma, then the vertex is, tell your neighbor what the vertex is according to that form. The vertex is, oh snap, there's a B. Miguel. H-K. Hands if you saw that? Yes? Alright, Saul, do me a favor, can you turn off the light over there? Alright, so, just ignore it, it's going to follow the light. Alright, so we're good with that from 1 to 5. How comfortable are you with this example? 5? So you're looking at the beetle and going like this. That's funny. Alright, on the next graph, copy this one. Make sure you copy the instructions because this is how the home plate is going to be. And it reads, graph f of x equals, oh no, not this one, this is too easy. This one. Example super cube graph, f of x equals x cubed, given g of x equals a times f of x minus h plus k, and then write the new transform function when a is 1/4, h is 5, and k is 3. Then graph the transformation. Give you some time to copy that. Copy. Alright, so for the sake of time, here we go. First things first. Let's graph this. So we get x, f of x. So we're cubing each value, yes? So what is -2 times -2 times -2? That's -8. Next, -1. What is -1 times -1 times -1? -1. 0 times 0 times 0, 0. 1 times 1 times 1, 1. 2 times 2 times 2, that's 8. Does everybody see where I'm getting these values from? Yeah, by cubing them, yeah? So let's graph this. -2, -8. -1, -1, 0, 0, 1, 1, and 2, 8. This is our parent function, cubic function. Alright, so let's now write our new transform function. Let's do that in red. G of x equals, now look, I'm going to leave a blank for the a. See how the next value is a? I'm going to leave a blank. And then f of x minus blank. And what did you guys notice? That this one didn't have an exponent, right? But we do need to put the power of 3 plus blank. So, what goes here? 1/4, yes. What goes here? 5. And lastly, 3. That's how you rewrite it. Fairly simple? Alright, so before we move on, once we move the final product, what would be the vertex of the final transformation? Tell your neighbor, please. What is the vertex of the final transformation? Everyone? 5, 3. So let's plot our point there, 5, 3. And I'm going to stop right there, but do you know what to do for the 1/4? Yeah, you need to do a little table, graph that, and then move it according to the steps. Alright guys, once again, your home plate for tonight, it's only 5 itty-bitty transformations. Have a good one guys, enjoy your home plate. See you guys tomorrow. Bye.